Hello, everybody, and welcome to the JS Roundabout in partnership with Kazoo. So thanks very much for Kazoo helping us get this put on. So we've got a couple of great talks today. First off, we've got Adrien from Kazoo giving us a talk on micro frontends and how to do that in React. And then we've got Ben from Tesco giving us a talk about breaking the monolith. What we'll do is we'll just wait a couple more minutes, maybe last few people log on, and then we'll go if that's okay first. If that's okay, chaps, and it'll be you up first, Adrien. Oh yeah, something to say as well is any questions you have about either the talks throughout the presentations. If you just put them in the put them in the comments, put them in the chats, and they'll pile up, and then I'll ask all the questions after. So Adrien, if you're ready, we'll start with you.
Yeah, sure. I'm ready. Okay, so just 1 second. Okay. Hi, everybody. Welcome to my talk about how to build micro-frontends with React. First, I'm gonna introduce myself. I'm Adrien Baron. You can find me on Twitter on Baron Adri, and I'm a senior software engineer at Kazoo. So what is Kazoo, you might ask, if you haven't heard of it. So Kazoo is not that. That might come to mind, but that's not what Kazoo is. Kazoo is the better way to buy your next car. So it's an online website where people can go and buy used car online. The whole flow is completely online. So you search for a car, you go through a checkout process, and you buy a car. All of that online. And yes, so it's basically your e-commerce website. But every item costs tens of thousands of pounds. So what does front-end look like at Kazoo? So we follow domain-driven design, which means we have separate teams that own the whole vertical of like a given slice of the user experience. So for example, we have the search and browse team, which owns like our homepage, search page, vehicle detail page. We have a My Account team, which I'm part of, which lets you see your orders. We have a consumer finance team, which deals with like people that wants to apply for finance while they're buying the car online. So every single team owns all those front ends. How do we deploy that? We use some microsite architecture. So we deploy everything on AWS. Our whole stack is hosted on AWS. So the way it works is each team is usually owning like a Next.js app we usually use. And all the pages they own are all deployed to AWS as independent Lambdas. And then there's an API gateway in front that does the routing. So if you go to the homepage or /usecars, which is our search page, you're going to end up on search and browse app. If you go to /account, you're going to end up on My Account app. /finance, you're going to end up on consumer finance app. So that's great. And everybody owned their old stack. They're very happy. And then suddenly, someday, someone comes and say, hey, wouldn't it be great to show a finance calculator that lets you, calculate your finance, what you can have for a finance agreement on the vehicle detail page, which is from search and browse. Or, maybe on My Account page, we're like, okay, like people would want to reschedule their order. So we would want to show like a slot picker where they can change a delivery slot. And delivery slot, all these kind of things is owned by a team called logistics. So the logistics team kind of should own that bit, and we want to show it on My Account. So you can see we have some kind of ownership problems that happens where we kind of want to mix things, not at the page level, but like at a more granular level. So for example, we want to put a finance calculator owned by the finance team on the vehicle detail page owned by search and browse, or a reschedule handover component that you reschedule a handover, a delivery, on the My Account owned page. So the way we solve that right now is quite like straightforward. We basically just have an API call like this, where we have the finance calculator component on the vehicle detail page, which does a call to an API that's owned by consumer finance. And we can see that one issue with this is search and browse on that front end. So search and browse has like within their code base, the finance calculator, which is like a UI that's like all to do with finance and not really to do with any of their business concerns. Another way we could be doing this, like another approach we could take, is say, okay, consumer finance is gonna own that front end, and they're gonna provide it to search and browse, which is great. And then that front end is gonna do an API call to, consumer finance API. One way to do that is with an npm package, but then we have like a deployment dependency between those two teams. Ideally, what we would want is the search page to, start and then be like, you know what, I want to get the finance calculator from somewhere and then get it, at runtime. So for the publisher, consumer finance, the people that provide this finance calculator, they want to own both the front end and the API of the calculators. This way they have like a whole control of all the user experience and know exactly what happens. And they can, iterate and do all sorts of experiments. They want to deploy that thing independently. They don't want each time they want to do a small change to that calculator to have to go see search and browse and say, hey guys, can you push the new version in production with like a new version of the calculator? That's a lot of team coordination. And they want to be able to test that component in isolation. They want to be able to say, okay, like that component itself, can I test it and make sure it works okay? The consumer of the component, search and browse, we want them to have like as little effort as possible. It's not their concern, like that calculator doesn't really care about what it does. It just need to be like providing some place for us to display it. They don't want to have to redeploy each time the finance calculator change. Same thing, it's like a concern for them. And want to assert the code behaves correctly against some kind of contract. So they want to make sure that given a certain version of the finance calculator on their page, if there's any interaction between them, they want to make sure that their code is going to behave correctly when that finance calculator does thing. Yes, for people like screaming in the background, that is Micro Frontends. So an initial approach we took to this is basically web components. We were going to be like, we experimented a bit with web components. So that's what it would look like on my account if we were to go with web components. So for example, you would have the My Account page, which has React and Start components. And then you would have a reschedule handover web component, which let you reschedule your delivery provided by another team. And another web component that lets you buy extra on your order, like basically add on to your order, which is also provided. One issue we see with this, or like a few issues we've seen with this, is so first, web components are great, but they do require polyfill for i11, and we still sell a few car a month to i11 users. So we don't want to drop the support right now, because a few sales lost when it's cars, it's quite important. React in web components, not that straightforward. Like we managed to make it work, but it wasn't really super easy. Style components, which we use heavily across all of Kazoo, are also quite hard to make work in the shadow DOM of web components. And finally, you have lots of duplicated dependencies. So it's a bit like you get React, and you get React, and you get React too. So what's Kazoo front-end stack looks like then? Well, it's TypeScript, React, and Start component. Because Kazoo grew like so fast, we only launched in 2019. The whole front end is using React, the whole front end is using Start components, and the whole front end is using TypeScript. So why not use React to do the glue to micro-frontends? Okay, so what it would look like some kind of React-based micro-frontend approach? Well, React unit of logic is like the component. So you would have some kind of component that comes from some, remote JavaScript bundle that you would load. So my account would be, hey, I need a reschedule handover component. I'm gonna load something from the network, and the component is gonna run within my context using my version of React and my version of Style component. can React load component asynchronously, you ask? Like this cute dog with a lot of question marks. Well, it can. If you've done bundle splitting before, there's like React lazy in suspense that you can use to load code asynchronously. Like basically doing Webpack is gonna split things for you, and then piece of your code is going to be imported at runtime. Well, React lazy is not magic. There's nothing like crazy happening. It's not like some voodoo. There's actually just a way it works. So the way, basically what React lazy expects from you, like this import statement, is just an async function that returns to it like a promise of an ES module with default export, which is a component that you're providing. So this code is totally valid if within that function, this get reschedule handover async, if it returns like, a React component, then that code would just work. What would it look like? Well, you'd basically see my account, have the suspense boundary while it's loading, and then the component's loaded from somewhere, and then hop, it appears on the page. Amazing. But how do we know what bundle to load? What a great question. So the approach we decided to follow to try to figure out what bundle to load at runtime is to have some kind of API. So I'll take you through it in 3 steps. So first, the My Account app is calling an API and saying, hey, I want the reschedule handover component, that like, slot picker thing, in version 1, like version major 1. The API is going to say, okay, for version major 1, the current bundle that's been deployed, the latest like iteration, is like this JavaScript file. My account is then going to load that JavaScript file from the network, and then it's going to find the component reference on window. So from like this approach, from the publisher side of view, the people that provide the reschedule handover, they can push non-breaking changes by just pushing a new JS bundle. So if they just update that API and say, hey, the new JS bundle is actually use this file, then the new component gets pulled by consumers. And for breaking changes, they just increase the version they push to, and then consumer will have to explicitly say, hey, actually, no, I want version 2 of this component, and they will start pulling like the breaking changes. For the consumer, my account, users get the latest iteration of the component and page load. Like whenever you load my account, it's pulling the latest components at runtime. And they need to opt into breaking changes, meaning they don't care about non-breaking changes, but when there's something breaking, they can upgrade the version and make sure everything works. What's not so great? Well, TypeScript type need to be duplicated. So both the consumer and the provider both need to know what is the type of the component they provide and they consume. The React and style component versions might be incompatible at runtime, so might not work. Consumer needs to know a lot about the bundled components. They need to know where to find the thing on window, all these kind of nitty-gritty things. And there's a lot of duplicate work because all the consumers need to know what this API to call and all these kind of things. It's a bit, there's a lot of duplicated things. From the consumer perspective, that API was much nicer to use. They didn't have to call an API. They didn't like an external network API or whatever. They just had like a function that they call and they get a component and they just like put it in suspense and that's all they have to do to consume it. What they care about, like the consumer, is saying, hey, given a major version of that component, what's going to be the type of the component I'm going to get, like what the interface looks like, and what version of React and style component do I need at runtime for this thing to work inside my app. Enter the contract, which is a nice concept we came up with. So basically, the providers, the people that provide the rescheduling component, for example, publish an NPM package. That NPM package has the TypeScript type for the reschedule handover component, a function called getRescheduleHandoverAsync that lets you like get that component at runtime, and the version of React and style component it needs to run as peer dependencies. So what my account does to consume that component is literally just add a dependency to an npm package. And then what we do in the code base is inside React Lazy, we call the get reschedule handover async version that's provided by that package. And it returns to us a component. And the main difference, the thing to be very aware here is there is an npm package involved, but the source of the component itself is not in the npm package. It's fetched at runtime, meaning it can change over time. And when you opt into a major version of the npm package, you basically opt into like, I want all like, on to a given contract, basically to a given interface of your component. Cool. So now what we have improved with this, the TypeScript type is now shared. Only the provider define the type and then share it through an npm package. React and style component version are checked with peer dependencies. So even npm 7 like throw an error if peer dependencies are not compatible. And consumer don't need to know anything about fetching component. They just have an async method they can use in React Lazy that return the component for them. What's still not so great, so the provider owns the whole micro frontend logic, meaning it knows all the work that needs to occur for sharing dependencies, how to push new bundle live, how to consume the latest version of a bundle at runtime. There's all this kind of logic that's like in every single person that wants to do a micro frontend, they need to know all those things, which is not great. Maybe we could extract this some way. Yes, we did. Created a library called @Kazoo UK Shared Libraries, which is internal to Kazoo for now. So what does this package do? Well, it abstracts how we publish and consume ES modules at runtime. ES modules because it's just a bit more abstract than React components, and it basically works with any kind of ES modules you would want. So it exposes a script that generates a Webpack bundle configuration to bundle a given component. It exposes another script that lets you publish that bundle to that API we saw. And finally, it exposes a function to consume that bundle at runtime. Let's go through a concrete example. If we go back to our my account example with the reschedule logistic components, well, logistic team on the repository with two folders, app, which is the source of the bundled components, and contract, which is the source of the npm package they publish for the consumers. So what is inside app? You have the source and test of the reschedule handover components. You have a simple create React app to run the thing locally to just make sure everything is working, or just to develop the component on your machine. A Webpack configuration that lets you bundle the components, and it uses the shared libraries thing under the hood. So they don't have to care, it's just like they configure it and that's it. And finally, deploy scripts that deploys the bundle to the CI, also provided by shared libraries, and basically knows all about like where to update things in our AWS infrastructure to deploy a new bundle. Cool, let's look at the contract. So it's just an npm package bundle with rollup. There's no magic happening here. It's published on our private npm repository. And it exposes, as we said earlier, the TypeScript type for the component and the function that lets you get it at runtime. That function also uses the shared libraries to handle all the logic about like, how do I fetch a remote bundle at runtime? From the consumer perspective, my account, this is just like, as we said earlier, they basically just have to add these npm dependencies. And then they have a React Lazy call that just called get reschedule handover async, which is provided by that bundle. And they take the resulting lazy component and put it in the suspense boundary. Cool. In conclusion, with that approach, a provider, the person that provides Micro Frontends, owns both the front end and the API, so they they can deploy the component independently as long as there's no breaking change to the contract. and they're able to test their component isolation because it literally just have a component on a repo. They can write a React testing library test against it if they want to. The consumer, they can consume the component with minimum effort. It's basically just another NPM dependency, but instead of importing the component directly, import a function that returns int async. They don't have to redeploy whenever the consume component changes. And finally, they can assert their code behaves correctly against the contract because they have the TypeScript interface of what they're getting, so they can mock it if they want to check everything is okay. And we have shared runtime dependency also, which is one of the cool added benefit to that approach. That is all. I would be, I have to say that Kazoo is hiring if you're interested. It's a really cool company to work at. So yeah, feel free to reach out. And you can follow me on Twitter at Baron Adrien, where I'm gonna post the slides of the talk. And also like a link to a blog article that has like code examples and more details than I got time to get to. Thank you very much.
Thanks very much, Adrien. Yeah, brilliant. So we've seen a few questions come through. So just a reminder, any questions at all for Adrien or Ben, just put them in the comments there, and then we'll go through all them at the end. So yeah, Ben, over to you. Breaking the monolith.
Cool. Right. Hi, everyone. I am Ben Mcgeachie. I am a senior software engineer at Tesco, and today I'm going to talk to you about something completely different, breaking the monolith. So, who are we? We're Tesco. We sell groceries. We're one of the big four. Our online services have come to the forefront of what we do even more over the past year, with our customers unable to physically visit our stores. We operate at very high volumes, servicing more than 1 million customers. At peak times, we're handling around 20,000 concurrent authenticated customers, making over 1,000 requests to our services per second. So yeah, high volume. Our groceries code base is largely a multi-tenanted monolith. It encompasses all the various aspects of a customer journey, from discovery through management of pending orders and into purchase history. This has provided the usual benefits that you get such a structure. We get the ease of code reuse between areas of concern and straightforward dependency management. It has brought along with it the usual drawbacks: tightly bound in dependencies between feature teams and increased complexity throughout the development and deployment stages. So, why are we making changes? My team, we're focused on the software platform itself. Rather than delivering the latest must-have feature for the product teams, we're looking at what we can do to improve not only the application as a whole, but the experience for those working on it. A less complex development and deployment process should lead to happier engineers being able to deliver more focused features more efficiently, which should be a benefit for everyone, right? Where are we going to make any changes? So, in order for any of the changes that we make to make any meaningful difference, we need to design them with full knowledge of the current estate at the front of our minds. Investing the time into exploratory work is going to be completely fruitless unless we remain cognizant of the limitations and requirements of the ecosystem that it's going to have to slot into and not only survive, but thrive. We've therefore taken steps back in order to be able to appreciate what the monolith actually does for us at the moment, where benefits could most readily be applied, and what shape they'd have to take. And there's no time like the present. While still operating at an internal level, we've taken a really lean approach to trying to answer the questions that we formulated about how to break up the monolith, so that we can gather momentum and start to develop real solutions for use by other teams. So, where did we start? We started by doing what you always do when you encounter any kind of new project. This one just happened to be at a much bigger scale than a lot of other things like features. We're talking about re-platforming a big web app. So we started listing what are our must-haves. Number one, server-side rendering. Discovery is a large part of Tesco's business. If a potential customer can use a search engine of their choice to try and find an item that they need, and in return they're served up a rich search result that takes them straight to that item on our digital shelves, then that potential customer is far more likely to investigate what else we have to offer, because Tesco doesn't just sell groceries. We want to use the UI components from our design system. Tesco has a really rich design system. It lives outside of the groceries application, and it's entirely its own thing. The groceries application is not the sole consumer of the components that it delivers. It's a really great resource, and it allows us to keep in sync across multiple areas of the business by presenting a completely unified interface for our customers. Dynamic routes and route params. Some of these are prerequisites due to the very nature of our current ecosystem. We're not going to be able to change everything all at once. Our products use an infinitely expandable set of IDs organized into categories that could very well change with the seasons or due to unforeseen variables, and we need to be able to respond to that without having to overhaul our entire routing system or systems at any given moment. Data batching and caching. So the high volume of traffic that we experience at peak times necessitates that we leverage batching of requests and caching wherever we can. Otherwise, the 1,200 requests per second that we get could very quickly become 6,000 requests per second. Try speaking to your DevOps about that. They're not going to like it. Localization and theming. So the groceries application does not only provide service for the UK. Our grocery sites in multiple countries need to be able to provide the same functionality, but with the localization of both text and branding to those locales. Focused domain knowledge for feature teams. E-commerce can be a complicated beast. You try and present the customer with the simplest possible experience that allows them to complete their grocery shop, but there's normally a heck of a lot that's going on behind the scenes. It's a fairly universal constant that we all need to shop for food. And with that universality comes variance. Someone might want to only buy 2 carrots. Someone else might want to buy exactly 600 grams. Someone else might want to buy a bag that's got roughly the amount they need. Now that experience is fairly manageable in a physical location. You give customers a loose tray of carrots, some that are already pre-bagged, some scales and some paper bags. In the digital realm, there's the barrier because of the lack of the tangible, which we have to surmount, all without making the shopping experience so dizzying that customers become confused and either end up with carrots that they never wanted or with a single carrot. This level of specialized domain knowledge doesn't necessarily have to be shared between teams. Does the team responsible for the logistics behind you being able to book a slot at your local Tesco in which you can come and collect your shopping really need to know the intricacies of how to manage everyone's carrot shopping preferences? Trying to hold the entire grocery shopping ecosystem in your head is a noble goal, but it's going to be far easier and far more efficient to create subject matter experts who understand the intricacies of their slice of the cake, right down to the finest crumb, and only have a brief understanding of the other elements involved. So, autonomy in feature team dependency choices. Similarly to the carrot conundrum, why would Team A be constrained by the choices of Team B or even Team C? They're more than likely not to have the same depth of requirements as their colleagues, and they should be allowed to find exactly the right tools to achieve their goal. A one-size-fits-all approach may give us easier dependency management, but does it really benefit our customers if teams are bound to rules not of their own choosing? Canary releases. So canary releases are a part of the wider Tesco roadmap, so they need to be supported with whatever solution we proposed. Straightforward deployments. Hallelujah. Deployments need to be uncomplicated and reliable. Each feature team ideally should be able to release any changes with the assurance that their changes are not going to cause any undesired effects in the wider ecosystem, but without convoluted dependency chains with any other feature teams. It would also be a huge boon if the CI environment for a given feature team was suited to that feature's architecture. Yeah. Single feature blast radii for errors. Now, at any given moment during a grocery shopping journey, there are actually a lot of ancillary things happening which can enrich a customer's shopping experience, but are not strictly necessary for them to be able to fill a basket and check out. In the case that there is a problem with one of those supporting features, we need the site to degrade gracefully and allow the customer to continue with their journey without interruption. We also looked at the things that would be nice to have, but weren't an absolute necessity. So our nice to haves, routing control by an external source or service, being able to alter the site structure and composition without having to update front-end code base would be just dandy. Framework agnostic. It would be really good to be able to pivot any front-end framework technologies without having to completely overhaul every piece of the system. Right now, a certain framework built by React is very much the one to go for, but who's to say in a few years it's something else? There's quite a list of expectations there that any new solution would have to live up to. So we started thinking about micro frontends, possible solutions. We did a bit of homework and started to look into existing architectural decisions that other people were already employing to get around similar issues that we have with scale. Should we use routing or routing where every path has a different application? Maybe we could build shared components that could be used to bind functionality together. There seem to be lots of different proposals out there, but none that quite fit what we were looking for. So one of our team members, a very intelligent man, recently pointed out Conway's law. It's an adage which states, I need to read this one, any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Now, that being said, we arrived at Micro Frontends. The article on Martin Fowler's site seemed to describe exactly what we were looking for, and it perfectly mirrors our communication structure. So that's the model we decided to try. A container application composing together feature applications to provide a feature-rich customer experience. Yeah, single page, multiple things feeding in. Micro frontends, gotta love them. We started by investigating various configurations of off-the-peg proposals. Get started nice and quickly. But after several iterations, we couldn't find one that was just right for us. We found that we had to create our own data fetching, routing, and layout solutions to layer over the top of the pre-rolled libraries. So we decided to investigate replacing the only three parts with our own and cutting ourselves free. So we started to look at those three key things for us. Routing. I worked with some Australians. I picked up the habit of saying routing, so I apologize if I flip between the two. We need a framework that will support both SSR rendering for the initial page load and internal client SPA routing for any onward journeys. Our routes are going to be a mixture of authenticated and unauthenticated, dependent on the route in question. Routes are going to have to be dynamic. They're going to have to be capable of taking parameters from one API response and building routes based in predefined business logic from another API. In an ideal world, we'll be able to update those routes without the need to redeploy any of the micro frontends. So for us, the ideal routing solution looks like this. We have a client which requests a route or a page from our MFE ecosystem. It goes and asks a config service for what it needs to do for that route. It gives it back some JSON and it replies back to the client with a page. Super simple. Layouts. We're only going to have a few layouts. Hopefully, they're not going to change a great deal. They are more high-level product decisions, which should unify different functional designs and present them in a manner that our customers are going to become familiar with. They'll be bound to routes with a couple of MFEs providing skeletons around which we can construct pages. Much like the routes they're intrinsically bound to, we really would like to keep those layouts separated away from the micro frontends to an extent that we can deploy one without having to deploy the other. So our ideal world for that looks like this. We now have the client, again, asking our ecosystem for a page. It goes and asks a config service of some description for what it needs to do for that page. It gets back some JSON, some data response. It can then go and pick up whatever HTML it needs from an assets content delivery network. And we use that to throw a page back at the client. Hopefully jobs are good. So, last of the trilogy, data fetching. At the moment, the Monolith follows a React with Redux model. The centralized nature of Redux allows for feature teams to share the knowledge of changes to data caused by events within the system. In a micro front-end ecosystem, the micro front-ends should not be communicating directly with each other. So how do we replace that inherent knowledge in our new world? We tried a few different options, but as with all of the steps that we've taken up until this point for our newer deal, we strove to make developer experience and simplicity both first-class citizens. So we decided on event-driven communication through an event bus. When performing any action that affects data outside of its scope, a micro front-end publishes an event. Other micro front-ends subscribe to these events. When an MFE receives an event notification from the event bus, it reacts according to its own business logic. This might even lead to more events being published. Super simple, hopefully. Pub sub through an external bus. So, looking at all those things, looking at the lessons that we've learned along the way, and trying to wrap that trilogy of things together into something that we can use as a reliable foundation to build initially the groceries micro front-end ecosystem, potentially more. We created the asparagus framework. The name is what it is. The asparagus framework is hopefully very, very simple. It only consists of 4 packages. The first, a core package, a router that uses Page.js to resolve routes and handle errors. It shouldn't ever need to be instantiated directly from any customer feature MFE, but instead it's used by the next 2 framework packages to create SSR and client instances of this singular router. So the next one, the server package. The server exposes a method which our container, or as we have called it, orchestrator, micro front-end, can create a server instance using that core router package. The server instance just returns asynchronous request handlers, which use the logic contained within the core package to resolve the route, build the response, handle any errors. Really simple. What about in the client? We have the browser package. So the browser package allows the orchestrator to create an instance of a single page application that can be used within a client. In addition to the exposed methods from the create SSR method from the server package, the browser package also includes an asynchronous en route change method to handle SPA navigation. It also handles the rehydration of data built up and the state of the application, or the state of the fetches and all of that. So that gets bound onto the window, and the browser package then handles the rehydrate. So we have the back and forth between the two. Last one in the chain, this could grow at the moment, much like Kazoo. We are using React. So there is a React MFE package. What this does is it allows feature micro front ends to create a React-based single page application micro front end module, which integrates perfectly with the framework. The React applications can be initialized really, really easy by feature teams. And this package handles the contract negotiation between the feature app and the orchestrator. It's also got some tidy little functions in there. So if you were to have, say, a basket on the right-hand side of your page, and you then changed route, and now the basket's on the left-hand side of your page, but that basket has context, it's been mounted, it doesn't actually get unmounted to be moved over to the left. It can be lifted and shifted from where it is in the DOM to another location without ever actually being unmounted. So you retain all of the state, all of the context that it had on its previous route. So all of these things in the asparagus framework channel down into the architectural decision I discussed earlier. The fact that we have an orchestrator. The orchestrator is our primary HTTP server and browser for our micro front end environment. It uses the create SSR method from our server package to give us an HTTPS server. 99% of the config here comes from either process environment variables or the configuration service. It's a simple and vanilla Express server. It was really, really important to us that we didn't cloud the implementation with layers of custom logic and expectations of hidden knowledge. The developer experience needs to be straightforward to keep any barriers to entry a minimum. It uses a configuration service to fetch and bind the routes, layouts, templates, the locations of the micro front end servers, and the import maps. In this way, any of these things can be updated without the need to redeploy the orchestrator micro front end code. Similarly, deployments of other micro front ends become much more simple as their release cycles are not bound together, but they live and die in the configuration service. Each of the past fetch methods that you can see there, fetch MFE servers, fetch layouts, all of that stuff, that's all they are. They literally use the fetch npm package to provide an asynchronous request for resources that resolves into JSON. The implementation for the client side of the orchestrator is even more simple to build. It uses the create SPA method from our browser package to give us a router bound to the routes and layouts placed on the window by the server package. The pair of solutions work symbiotically to give us what we think is an elegant solution that is both performant and puts developer experience at the forefront. So what does a feature micro front end look like? Yeah, really simple. So for a feature micro front end, this is the contract between that application and the orchestrator. It brings in the create React MFE method from our framework React MFE package. it brings in its root component, and it exports by default this. So that name there is known to the configuration service. The root component is just a React component, and it binds it all together. What do routes and layouts look like for these things? So the top one there, that's a layout that's coming back from our configuration service. As I said, it knows the names of the micro frontends, but not much else. And below that is a root. For / use the layout single column. That's the layout that's above it. And for placeholders, for that main section there, use the MFE homepage. That's easy. That's it, super simple. At the moment, it's still an internal package. It's very much a work in progress. We hope to be doing a lot more with it in the future. We hope to be able to share it out. We are also hiring. Hit up our careers link or email Lauren and tell her that you saw this and thought it was awesome. That's everything from me.
Thanks very much, Ben. It's good to know other people go to supermarkets to buy just one carrot like me. I'm not alone. Good to know. Yeah, thank you. Oh, we brought Adrien back as well. So yeah, we're just going to run through a few of the questions. Obviously, if you've got any more for Ben after just hearing the talk, just put them in the comments there, and we'll run through them. Right. Let's have a look at some of these questions. I had one question. I'll go at the start from Dobroslav. How are the micro front ends coupled? And what's the difference between micro front ends and microservices, if any? It was directed at Adrien, but Ben, you might have something to say on it as well.
Adrien, do you want to field it, or do you want me to?
Oh, I think you might be on mute, Adrien. It's not a meeting. It's not an event if someone's not on mute.
I thought we were going to get through at least one video chat without being on mute. But no, it's happened. I think he's still on mute.
No, I don't think we can hear you, Adrien. Ben, do you want to answer that one first, and we'll come back to Adrien?
So, micro front ends, microservices. To me, micro front ends are a front end kind of, well, microservices have come to the forefront recently in terms of how we deal with technologies from the back end. It feels like micro front ends are a response to that. It feels like micro front ends are microservices for the front end, but it's slightly more difficult. Like, say, if we have 3 distinct entities coming back, as 3 different entities of data coming back from our APIs, the lines between those are much easier to draw, but in a front end or in the actual UI, it's much harder. So it really does tend to, when you get into larger companies, that's why when my colleague brought up Conway's Law, it's like, yes, that really is what it is. Like, we have these internal divisions within our software development that should never really be apparent to the end customer. But for us, they're intrinsic in everything that we do, because this is our team, we do search and browse. This is that team, they do checkout. Like, never the twain shall meet. But micro front ends to me is about keeping those 2 things as separate as they should be, but never letting the customer feel any degradation in service because of that. Hope that helps.
Fantastic. Adrien, did you have anything to add on that?
Is my audio back?
Yes, we can hear you.
Yay! I started a prototype. Anyway, yeah, I totally agree. Like, that's definitely what I've like. Yeah, I don't have much to add on this. At Kazoo, we do use microservices on the back end for almost everything. We use basically only Lambda, like everything's deployed on Lambda, and we use event-driven architecture. And so this is an architecture that let us like have each team focus on like what they care about. And the like microsite architecture worked quite well also, but basically, yeah, like the micro frontend lets you as you said, Ben, get each team care only about the piece of the page that they care about.
And you don't have like 4 teams developing the same header, right?
Yeah, exactly. Yeah, also that avoid like duplication, stuff like this. Yeah, for sure.
Fantastic. Sam asks, do you use React Router for your links on the front end?
I think that one was for me. And I think that I saw it earlier, and we usually don't. We use Next.js. So for most of our front ends, so we use the next link, meaning that it's initially server-side rendered and then navigation on the client or client side, as long as you stay within one microsite. Yeah.
Fantastic. And just whilst I'm on the questions for you, Adrien, Nicholas asks, do the micro front ends remain cached when switching between different micro front ends?
So when you switch between different apps, we don't cache the API call that like returns what current version of the bundle is. So that call is not cached, but the bundles themselves are cached. So if you leave like a page and you come back, or if you use the same micro front end in multiple like places, like in multiple microsites, then the bundle is cached.
Fantastic. Ben, Dobrosov asked, why are you using asparagus instead of something like Next.js?
So we did play around with a few different things, and the one that got closest to where we wanted to be was single SPA, one of the strangest named packages out there. But we just found it was so close, but just not quite what we wanted. So we took a lot of the ideas that they had and we thought were very good ideas, but we made them our own and we added new stuff on there. The plan is, at the moment, it is React based, but the plan is to be able to use it with almost anything that we want. We've tried to keep it very, very agnostic in terms of technology choices. We've gone for the most simple and the most vanilla application of packages that we can. So there's very little custom logic actually in there. There's a few key bits, but there's nothing earth-shaking in there. It's all focused on, if you came to work with us and you sat down at an IDE for the first time and you saw the code, you should be able to get going pretty quickly. There's nothing hidden. There's nothing crazy. But yeah, we did look at Next. We looked at Vue. We looked at a whole bunch of different stuff, and this is where we are because this is what really suited us and ticked all of our boxes.
Brilliant. I had one for you actually, Ben. Obviously, you talk about sort of breaking the monolith, and it's such a huge web application that you've guys got. How long did it actually take you to, I guess, unpick everything and replace all these sort of legacy systems with these new micro front ends?
We haven't started it yet. At the moment, we are still. This is very much proof of concept. We are starting to get it into production ready code. We are on the path, but it being what it is and having the amount of customers that we have, we've had to make sure that it's right first. And we've gone through and we have hooked it up to real backends. We've hooked it up to real data just to make sure that we're doing the right thing at every step. We've stepped back and gone, right, is this the right thing to do? Can we do any better? Can we make this quicker? Can we make this more efficient? And we're now at the place where our big questions are answered and we can start thinking about getting this to customers.
Yeah, I suppose with this huge, I guess, increase in online shopping, it would be quite tricky to sort of do all these things right now. And
it'd be the whole tablecloth trick, right? Just just hope that it all goes okay in the middle of a pandemic. We'll just
Nothing moves.
Adrien, I've got one from you from Abhijit. Do we have just one micro front end or a couple of micro front ends mapped under a single DNS?
So we have I'm not sure I get all of it, but we do have multiple micro frontend. Like the idea is for each team to publish their own micro frontend, which is going to be like a JavaScript bundled. And then like we do have, so it's all served as our static file, same as the rest of our JavaScript bundle on the domain. And then when you navigate between the pages, it like this browser is just gonna fetch the bundle it needs to display that component.
Brilliant. And last question for Ben. What's the story behind the name asparagus for the framework?
So one of my colleagues who's new to the team recently said that he thought it was because it was like all of the different asparagus shoots bundled together in twine, like that picture you saw there. And that's brilliant. That's a wonderful explanation for it. The reality is that one of the software development managers and one of the architects, no, is he? I'm not sure. One of the senior engineers have a big wheel of fruit and vegetables, and they span it. And I think asparagus came up for a previous thing, and they didn't like it, so they span it again. But then it came up with asparagus twice, and they decided it was fated, and that was it. It's no more complicated than that. I'm sorry. There's no exciting tale behind it.
Yeah, thanks very much, Ben and Adrien, for your talks, and obviously thanks to Kazoo for helping to put this on. And you can't see her, but thanks to my colleague Beth in the background who does all the heavy lifting for this. So yeah, we'll get the video posted on the group as well, if you ever want to watch it back. And yeah, thank you very much for logging in.
Thanks, everyone.
Goodbye.
Thanks, everyone. Bye.